everyone, welcome back to my YouTube channel. Okay, so today we have a new project. It's a follow-on project from a project that I started 45 weeks ago. So the sun's out, we're sitting at a beautiful location, the River Foyle. So I'm actually sitting on the end of a pier here, so hopefully nothing falls into the river. Okay, so this video will be focused on creating building this little mechanical mechanism. So it's the start of the handheld device. So it's not complete, but it's getting there. So yeah, moving on now. So I want to give a little discussion first on this little template that I showed back in part 1 of this project. So this template was it's for another project, and it's a project that I'm creating for my girlfriend. If I bring it up close here, you can see the sort of idea of what I'm trying to do. So I'm looking to create a wire frame with 40 rings in the middle of it. We have 4 main bars that surround the rings, and each one of the rings is welded 4 places to these rings. So yeah, I'm not going to talk about that too much, but here is the rings. So the rings are complete for that project. So again, this is not a part of the miniature spot welder or the wire frame welder. It's just parts for another project that I'm creating this project for, not to be confusing. So we also have these 5mm bars for the other project. So these, if I hold this up against the template here, one of them, these form the hard structure. So these is already all completed. The only thing I need now is this miniature spot welder. I don't want to use a TIG welder because the welds will be visible and there's a lot of heat put into the stainless, and I don't want that because I only distort what I have done here with these little wire frames. So this video is focused on this, but before I move on to this, I'm going to put this on the ground and I'm going to talk about it. I don't want nothing to fall in the river, so I have to be careful here. This is the template. What I need to do with this miniature spot welder is slide against each of these little rings like so, but to do that I also need another piece of copper that creeps in through each one of these holes to weld the rings in 4 positions. So there's 40 rings, so there's 4 points of interest that I need to weld. So that's 160 holes that I need to this device to go on through, if you get me. So I'm not going to get into that. What we're doing for the meantime is creating a miniature spot welder. So we'll talk about that in later date, maybe when I do part 3 of this handheld device. But now I'm going to keep talking on here. I'll take the camera to the ground and I will go through this little piece in detail. So before we start going on to the manufacturing, the video clips that I've created over the last 3 to 4 weeks. So this is another copper bar that will be interlinked to this part, which will make the one big component, such as a handheld device. So what I'm going to do now is I'm going to put it on the ground here, but I should mention too, part 1 was focused on the high current side of the spot welder or the wire frame welder. It was also focused on the control side, so the controls, the foot pedal, the low voltage side, controlling the relays, controlling the high voltage transformer, which is a microwave transformer, or 2 of them combined. So I'm going to put this on the ground now. I might put it on this board, and then we're going to I'll put it on the pier here. I'll bring the camera down here. So what do we see? So as you can see, I'm on the edge here and I need to be careful. So I might just go zoom in here first. So over here we have Ireland. Obviously this side is Northern Ireland. The River Foyle splits the two. the two countries, and I am sitting in Northern Ireland. I had a kayak one time, and I still do, and I kayaked to the other side of this, but I haven't done it in a while now, so I might do it again. I might do it next week, you never know. So if we go on to this little handheld device now, what do I see? If I take it over here, I'll take it over here away from everything else. So this little smart device, hopefully you can see that because the sun's out and I can't see the screen that well. So this little smart device has stainless and copper combined, but it's got a really important feature. So this copper bar and this stainless piece is isolated away from each other. So when I go to actually mount my high current, my high tension cables to this device, one of them will be connected to this electrode, this copper bar, and the other one will be connected to this body. So this body contains 5 pieces of stainless, so there's 4 sides, and then there's a back plate here. So hopefully you can see that. If not, I'll push this back out of the way. So you can see it there now, look. Do you see the way there's like a mil air gap right around the copper? That's really important. So you don't want them 2 pieces, the copper alloy and the stainless touching. Otherwise there'll be a short circuit of the high current transformer. So you can see how easy it slides there on the axis. So it slides on one axis. This is going to be where it pushes out to the other copper electrode, which will be round my finger position, and it will put pressure on the 2 wire pieces, the 2 wire bars, or should I say the 2 stainless bars, making the wire frame in the end up. So this device is smart because it's got 4 insulators inside it. The video clips that will follow focus on the entire making of this. So at the end here we've got a C bracket or a U bracket. This bracket is bolted with 2 M4 dome stainless bolts. And if I was to take these dome bolts off, let me get my words out, the insulators can be slid out if need be in the future. Let's say that they become tarnished or burnt with the heat. Keeping in mind that they are high temperature, but they will degrade over time, depending on how much use I get out of this welder. So what I'm going to do here now is I'm going to jump straight into the video clips, and hopefully I haven't waffled on too much. But just to say again, if you look at this end, it's also got the 1 mil gap between the stainless and the copper. So the only time the voltage will ever jump over a distance like that is if it exceeds the into the kilovolts. Obviously I have demoed this in part 1 that my transformer output on the secondary winding, the 2 transformers combined, is only 1.75 volts, so it's very, very low. So it's safe working voltage. So we're going to move straight into this now, and we're going to start showing how I made it. So I'm going to start off with the insulator boards and take it from there. Okay, so I hope everyone enjoys, and hopefully I haven't missed anything here. I'm just trying to think. So it slides in and out on one axis. It's really sturdy, the copper bar. I have the camera in my hand, but if you see my 2 fingers, it's really sturdy. So this copper bar always stays parallel to this to this stainless body on the 2 axes, if that makes sense. So if I go up and down this way, there's no play, and if I go up and down this way, there's no play, but it just slides in and out, nice and easy. So that's it. I hope everyone enjoys the videos that will follow. It's going to be very long because there's a lot of work in this, but well, we'll take it from there. Okay, so I had to come in the van there to do this. The cows were doing a lot of roaring out the back side of the garage. So what I'm going to do here now is I'm going to start sketching it, the handheld device. I'm going to start somewhere, so you've got to start somewhere. So first things first, so we know we've got 2 electrodes. So these 2 electrodes need to be isolated away from each other, so there needs to be an insulation barrier between them. So it being fiberglass wood, anything like that, but obviously I'm not going to use wood or plastic. But this piece of this insulator that will surround one of the copper electrodes, it needs to be also able to stick high temperature. So what I'm going to do here now is I'm going to start drawing this out, and hopefully you get the gist to what I'm doing. So I'm going to start by creating a sort of like a pocket out of stainless steel, which will hold one of the electrodes nice and tight, but it allows the electrode to move on one axis in and out. So if I draw this here now, hopefully I don't hit the camera here because it's kind of awkward the way I'm lying. So we have a square, sort of like a capsule, that goes back approximately, say 40 mil back, 40 mil deep. So I'll get that in a minute. So what do you see that? So if I have 4 flat plates that are welded together like so. So these flat plates being 2mm gauge, so 2mm thickness. So keeping in mind this is only 15mm wide on the inside and 3mm deep. But I'm just drawing it to this. It's not to scale at the minute. It's just for us to describe this process of what I'm trying to do. So this is going to be like the main body of the little handheld device. So if I have a metallic, this here's being stainless, which it will be. If that's stainless steel, and we have a copper electrode running up the middle of it, we need some sort of a barrier between the copper electrode. This being the copper. That's the copper electrode, and say it's positive. We need some sort of barrier on here, like an insulator. But this insulator also needs to be hard wearing and also high, be able to stick high temperatures. And also we want this insulating material to be nice and tight so the electrodes meet on point the way they should do. So I'm going to start doing this body now. So it's going to be 4 pieces of stainless. We could weld to this, we can do anything to it. Say if I want to, say this is one electrode coming out of here, like so. We have one electrode coming out of here, and we have a curved body on it here at this point, a curved edge, sort of like this, that will sit or rest against the wire frame as a weld point. So it's going to be a crimp point even, so like a pinch point. So what I'm trying to say is I'm going to have another one of these running off this body. I could either bolt to it, this body, I could weld to it. I more likely will be welding it. So I'll probably end up welding a bracket, like something like that, that will contain the other flat bar, depending on where it needs to go. This electrode needs to run on up to this point, where this one will slide out. So I know it's only a wee sketch, but it gives you an idea of where I'm going here. So I'm going to start doing this body now out of stainless steel, and hopefully it all goes well. Okay, so we need 2 pieces of fibre for the sidewall. So sidewall, the depth of the fiberglass on the sidewall is going to be 7mm. So that's allowing for 3mm for this face and 2mm to either side of it. So here we go, we're cutting it with a Stanley knife here. Just checking the measurement. Good. Hopefully this breaks now. Okay, so I have the 7mm fibre board tracked, 7mm little cutting that I need. So what I'm going to do here now, I've put a new blade in because obviously we're cutting like a glass fibres here. So I'm going to move on and do the 15mm strip for this side. So we need 2 of them again, so that is long enough. So starting here, just keeping in mind the wee capsule pocket that I'm making is going to be 30 or 40mm deep. So I'm just going to cut the full side here. So again, tracking 15mm this time. Don't want to do much filing this because there'll dust come off it, so first cut. So if I put pressure on this now and track it again. So I'm going to keep cutting this, put a mask on. Okay, so what I'm going to do here now is going to use this little press brake just to break the track that I have created here. So the two of them. Hopefully we have a good side, and we might have a side that's a wee bit bad, but it doesn't matter. We can place the side to the stainless. So we're going to do that now. I'm going to press it here or fold it. So we'll start with the 15mm, and hopefully it turns out okay. So making sure it's at the 15mm distance. Let me see if I can get on here. Okay, so I think it's near enough there. So if I give that a wee press there now. There we go. So we sort of ripped it apart. So the Stanley blade wasn't much use. Well, it was good enough, but it wasn't. I thought it would be easier broke than that, like. So what I might do here now is I might tidy this up with the grinder and wear a mask. We need the 15mm strip, and we also need the 7mm strip. So let's be careful with this one because it's going to be quite wide. As I say, I can tidy it up with the grinder and a mask. Okay, so you can see there that's much more than 7mm folded at the back. So it's we'll fix this now with the grinder. It's probably the easiest option here. Okay, so I got there in the end, cutting these fiberglass strips. So obviously they are approximately 300mm long now, so what I need to do is cut them to length. I haven't made my mind up yet what I'm going to do here. Am I going to create this body, this guide to be 40mm long, 30mm long or 20mm long? I'm going to cut the stainless strips and then I will make my mind up. So, what do we see now? So we have this piece of copper sits on top of the fiber board. The insulator. We have this 7mm strip sits at the side, like so. Then there will be another 7mm strip at this side. We'll have another 15mm strip at the top. That then is isolated from the metallic body that I'm about to create here now. So to create that, I've mentioned I'm going to use this stainless. So this stainless needs to be 15 plus 2 plus 2, 19mm wide, and by 7mm deep to match this edge, this wall, this fiberglass piece. So I'm going to do this now. I'm going to start cutting the stainless. Again, I'm going to wear my face mask to protect my lungs, as the stuff I'm working with is quite dangerous, the materials. So, especially this fiberglass. So, I'm going to do that now. I'm going to start cutting the stainless here in the body, and hopefully it all goes well. Okay, so I mentioned there the stainless little body needs to be 7mm deep by 19mm wide. That's actually not true, so I have to allow for the new depth, which will be the stainless steel plate at the bottom and the stainless steel plate at the top of the insulator. So that will be 11mm deep by 19mm wide. So I'm trying to keep the fiberglass, this little line here where it meets, overlapped all the time. So when I have these strips cut, so I need two at 19mm wide, and I also need two at 11mm wide, which is the depth. So this will enclose, these little strips then will enclose the electrode, this copper bar, and this high temperature insulator will do its job. So I'm going to start cutting that now. I was going to start marking it out here first. So 19mm first. So I'm going to cut this with a grinder. This is more polished. It's approximately 100mm in length here. I will obviously cut it down on the end up. So you can see a wee fine line there left by the verniers, 19mm. So I'm going to cut that now, and we're going to then move on, do another one, and another one. So until we have 4 plates. Okay, so it's got very windy there now, but I'm going to keep cutting these. Then we will move on and start filing them. At the minute, this stainless strip is currently, what do we see, 19.3. I want it down to about 19.1. So I'm going to maybe cut these 3 strips and leave the rest for a new day. So again, we're going to scribe in our line this. Okay, so the final 2 strips, one, well, both at 11mm. So here we go, scribe a new line. One more, 11mm for the side. Okay, so I'll give these a little file now and we'll start welding something together. Well, of course we have to cut them to length yet. The 4 plates and the 2 fiberglass boards. So I'm going to put everything in view here. So we've got the, what do we see here if I bring the camera around? So we've got the 4 plates. So these will be probably cut down to 40mm length. Between 20 and 40, we have the 2 copper electrodes and we have the fibre boards. So we'll start filing these now. Okay everyone, so a new day. So it's a week later. It's a week since I done anything on this little spot welder, a wire frame welder. So following on now, so last week I have cut these little insulators. Using a Stanley knife, tidying them up with the grinder. I have also cut these stainless steel strips. We have 4 of them to make the little sliding device, the little capsule that will hold one of the electrodes for the mechanism, the welder mechanism. So what I'm going to do here now is I'm going to do another sketch. I know I done a sketch last week of the outer surround. It looks something like this. So it looks something like this, and I demoed how I'm going to place the flat bars on here, or sorry, the flat bits of steel. I think I demoed how I'm going to place the insulators on the inside then also. Oh. So the insulator will be a barrier in here that will keep the 2 electrodes isolated from each other. So work can be done with the welder or the transformers. So my next step now is assembling this little, I'm going to call it a pocket or capsule that holds the insulators. But once I do that, I need a way from keeping the insulators from falling out. So a face here and a face at the back. So keeping in mind, I haven't touched on the other electrode yet. So the positive or negative. So this is probably going to be the positive electrode on the sliding one. And the negative one will be the body, so the ground of this handheld device. So my next step now is, what do we see here? I got a new bit of paper. I'm going to create two faces. The two faces will be done using this, or created using this 2mm mirror polished stainless too. It will have a tiny slot on it, like so, to allow the electrode to follow through. So this is the copper electrode. There will be a gap between this face and the electrode of approximately about 1mm. So I just need enough of this face to hold 1mm of this insulator in, if that makes sense. So when these are contained in this capsule here, I will then, one end will be fixed and the other end won't be fixed, so it'll be either screwed up here at this point, and there'll be a face on here too, and there'll also be like maybe another some sort of fixing bolt at the other end, or screw. So this then will be the main part of the mechanism for the spot welder, and I then can come off this with anything to create an arm to hold the other electrode. So this other electrode will be held with this body part. So it's a lot of detail here, but I'm just trying to explain it as best as I can. So this copper electrode will either be screwed at this point, fixed, and this one will slide in and out to meet the other one. And this will be set using tension with a spring or something like that. So my next step now is to create these faces. So I'm going to start I'll assemble all these bits of stainless together first. First things first, I have to file them, and these have to be perfect. So these, what do you see, if I get this together here? I'll put this together first here just. So I need an insulator, a face, we need the copper electrode, we need another insulator on top of this one, and we also need another face. So this is the body of the welder. What I'll do then is I'll place another, the sidewall into this gap, like so, and I'll place another bit of fiberglass, high temperature fiberglass at the other side. So you can see there now, it's sort of coming together. So this copper electrode will be able to slide in and out whilst it's isolated from this. Another thing I'm keeping in mind here, once this is done, a wee bit of grease or anything will be applied to the copper bar to keep it from wearing into the fiberglass. So again, a lot of detail here, but I'm trying to cover it as best as I can. So what do we see now? So if I put the sidebar on this now, the sidewall shall I say. Let me see if I get this together again now, it's sort of falling apart. Okay. So this little device here, the sliding device, will be either 50mm or 60mm long yet. I haven't made my mind up. So what I'm going to do is I'm going to assemble it at 100mm, and then I'm going to cut the whole thing together. So these are the sidebars for the side. So basically when I have this done, these fiberglass parts can be slid in and out in the future. That's why I'm making one of the end caps, so it's not fixed. So it's going to be mounted somehow. This is a side plate that will be welded in place in the next video clip, hopefully. Of course I have to do a bit of filing first. This then will be welded at this side. So you can see, oh, it's falling apart now. So what I'm going to do here is I'm going to start assembling this, and hopefully it all goes well. And I hope you enjoy. A lot of detail, but quite interesting. Okay, so I'm ready to go here. As you can see from the red fiberglass particles on the file, I have already started here. So okay, so if I measure this copper electrode, the width is 14.68. If you look at this little fiberglass board, you want it the same size. You don't want it smaller, and you don't want it too big because you don't want too much play where the electrode is contained, where it is held in position. So what do we measure this now? So I've got this down to 14.69, 14.67 there, and this side is 14.73. So what I'm doing here basically is resting the little fiberglass sheet material, little piece against the file, keeping it perpendicular. If you look at it this way, you can see it is 90 degrees to the file, so you want the edge as nice and square as possible. I should be wearing gloves here obviously because this is glass and you can feel the wee bit sticking into the skin here. So what do we see? Should also be wearing a face mask, but if I was wearing a face mask you would not be able to hear me talk. Okay, so you get the gist anyway. If I measure this now, it doesn't take much. So if I measure this now, 14.68. That is absolutely bang on. So if I measure this, 14.67. 14.67. Can you see that? Yeah. So if I measure electrode again, 14.67. So that's how accurate I have these pieces. I don't want them undersized because you don't want the electrode being too tight. Because when I weld the stainless together, it will tend to crimp in, like so, with the heat. So I'm going to keep filing these now. You can see this 7mm one, so I'll do a wee test on this too. Okay, so if I measure this, it is measuring 7.06. The electrode, the width of the electrode is 2.89, and the width of one of these plates is 2mm. So 4mm plus 3 is 7. So if I put the plates together just to demo this, so what do we see? If I put this on here like so, and this on the bottom. Okay, so I'll just use the proper plates. So what I want here is I want this fiberglass to sit nice and tight in between the two stainless plates. So it looks much like pink wafer biscuits you used to get. So if I measure between the two bits of stainless, it is measuring 7.08. So again, that's bang on, perfect. What do we measure it? So that's what we want. So we don't want any gaps, air gaps on there. We want a nice, neat fit. So I'm going to keep filing these here, and then we're going to start welding this together, and then we will get the correct length. It being 50mm or 60mm, we will see. I might leave it at 100mm for the meantime. Just to get an idea of what way this little mechanism's going or shaping out to be. So yeah, I'm going to keep filing here and we will start welding in a minute. Okay, so now that the adjustments is made to the fiberglass pieces, the little parts, shall I say, I now need to make final adjustments to the stainless sides. So if I was to bring all this fiberglass little capsule or insulator together, if I measure across at this point, so that's measuring 18.82 millimeters. So I want my stainless steel sheet, stainless piece, the width to be approximately, so I don't know if you can see that there, nice and clear, can you? Take my word for it, it's 18.8. So I want my stainless piece to be approximately a tenth bigger, or a wee bit less. So I'm now going to tweak these plates. So if I measure one of these plates here, you can see it's, when I cut it, it is 19.07. So I have to take 2/10 approximately off this and this one is probably the same. So it's 19.14. We have these sidewalls that are meant to be 11 mil. They are 11.29. So I'm going to tweak these now before I start welding this together. So I'm going to use the grinder to do this and the file. So here we go. Okay, so what I'm going to do here is I'm going to do this off camera because there's a lot of work in it. Some of them there is measuring 19.4 at one side. So I have to focus here and get these perfect. Then I will start doing the video on the welding or the tacking up stages. Yeah, so here we go. Okay, so I've been working away in the background here. I have the 4 plates up to spec. So basically what I've done here is I've grinded them down to the fine line that I scribed in the stainless. And after that I have filed them just the same way I filed the fiberglass parts, the fiberglass boards. So again, perpendicular to the file and basically going back and forward, full strokes off the file to get a nice even finish or flat surface or flat edge, shall I say, just like so. So if we look at them faces now, you can see like a nice brushed finish from one end to the other, so there's no dips. Quite a low tolerance. So what do you see? If I measure this now, I want it 18.8 mil. The reason I want the 18.8 is if I go back to this, oh, this fell out. If I go back to my copper, or sorry, not my copper, my fiberglass parts with the copper bar. Oh, sorry, I'll just drop it 2 side bits. So if I measure this, what do we see? We need the side bits actually to take this measurement. So if I measure this across the width, it is reading 18.8. So I need a bit of stainless that wide, 2 bits of stainless that wide, one for the top and one for the bottom. So if I measure this now, it is measuring 18.81 thereabouts. So if I measure the bottom, it's measuring 18.85. So quite a low tolerance, so that's good. The closer we get that value to 18.8, the less air gaps inside it and also less movement of the copper electrode. So the next step now is I have to tack this together. So in order for me to tack this together, I'm going to basically assemble the whole lot of it, set it all together or into the wafer first. So if I go with the copper bar first, the 2 insulators top and bottom, then we'll go for the stainless sheet, the stainless part, bottom part, and then we'll go for the stainless top part. Then we'll place the little side insulator in to look how neat it fits. Next step is this sidewall. So I'm going to trim the length of this little module or this little device when it's welded together. So I'll do this first. So placing it on the 2 sides, quite tricky. So that's it. So everything's in there, apart from this last little fiberglass part. So it's important to put them on for assembling it to keep everything nice and snug and tight. So what I'm going to do now is I'm going to tack this little, what can I call it? Little device, part of a device for the meantime. It's getting there like, so capsule or whatever slide mechanism. So I'm going to tack it in maybe 3 points for the meantime, and then when I cut it, well, I might add, depending on the length of it, I might put more tacks to one end of it, depending on where I'm going to place the cut with the grinder. So I'm going to start welding this now and hopefully it goes well. So we're going to set it on a flat surface. These edges should be flush. I have them exact down to the 10th of a mil, so yeah, let's go. Okay everyone, so it's been a week again. So I previously started this little hand device, and I got distracted by the poor light quality in the garage. So what I've done is I went and upgraded my lights, and much brighter now for the project. So I'm going to start assembling this little hand device now. I have the little aluminium strips ready to protect the mirror finish on the device itself, so when I attach the earth clamp from the welder on it. So what I'm going to do is I'm going to start tacking this together now, and yeah, take it from there. Okay, so final checks before we start welding here. So if I measure this, it is measuring 6.8 and 6.73. So it is a wee bit tighter than I'd want, so we're going to give it a wee press out here. That's because I've moved the insulator and all back. That's why it's become a wee bit tighter. It should be 7mm. If it's 6.9, I wouldn't really care. So okay, so it's still measuring 6.8. You know what? We'll go with it. It'll do. We'll tack it and we'll see. So I'm going to tack this face now in 4 places. So hopefully it goes well. It's better tighter than too slack. So here we go. Okay, so that's the 4 edges, shall I say, tacked. So what do I zoom in here? So hopefully you can see that. It's quite difficult to see, even though I upgraded the lights in the garage. So there we have 4 tacks at the face. So what I'm going to do now is I'm going to remove this clamp and see how the copper bar is performing with the pink insulator back in its position. See if it's too tight or see if it's too slack. Then we will move on to welding the rear end here. So here we go. So it looks good. So I'll wait till it cools down a bit. It's cool enough. Okay, so that's quite tight now when I'm pushing the pink bits in, so it's good. I think it'll be okay. So when I push the copper bar, there we go. So it's still able to move. So what I'm going to do now is I'm going to push them forward and weld this rear end, and then we'll put a few more tacks down it. So we're going to put the clamp back on it here. Okay, so I have the front face welded, tacked. What I'm going to do now is I'm going to weld down the body a bit, sort of about 60mm down. I don't have to go down the entire way because you do know I'm going to cut it in half. So just checking that the little insulating the little barriers back far enough so we're not going to burn it. But we also need that barrier there to clamp it. So what do we see? It's quite tricky, this process. Okay, so I'm going to say it's okay at that. So here we go, welding it again, tacking it. I'll zoom in here. Hopefully you can see that. Kind of difficult to get it all in view, but here we go. Okay, so 2 wee small tacks, just fused together, 20 amps. I'm going to turn the welder up a wee bit for this one, even. Okay, so we're now at 25 amps. There we go. So we'll turn it over the body and tack the other side too. Okay, so I have decided to cut this little mechanism, the axle body, at 50mm because assembling it's more difficult than I thought. There's no point in me making things more difficult than need be, so rather than tacking along this face, I'm going to tack it the same way I tacked it here at the front face. So I'm going to set my length at 50mm now, so that's 50mm that the copper bar can slide back and forward on. So I'll cut this now. I have the line marked here with the scriber. Stanley knife at 50mm. So we'll do this now. Okay, there we go. So what I'm going to do here now is I'm going to square this face up and tack it the same way I did this one. The reason I cut it short is because when I was tacking the middle here, the face dropped down with the Jenga block. So rather than squeezing this down tight, I'm going to just use 2 bits of metal instead. And yeah, just tack the outside face rather than the face, if that makes sense. So rather than welding down these lines, I'm going to weld the face here 4 points. Okay. Okay, so that's near enough. I have grinded, leveled it up to the scribe lines. So yeah, we're going to start tacking this now, just like we done this face. And then we'll put the insulator, the bar back inside it along with the copper bar. Then we'll start making the faces here. This one will be fixed, and this one at this end, either or, will be mounted. So here we go. Okay, so much trickier than I thought it was going to be honest. So I'm going to measure this again now at the other end to make sure it's within the same size as the other side, same dimensions. 6.8mm. Okay, so 6.8, 6.8, and the other way should be okay too. So we'll tack this up here now, and hopefully it isn't too tight. I noticed that the other end was a little tight when I went to place the insulator in, and with the copper bar. So we just have to work with it and maybe file the insulators a wee bit more, take a wee bit off them to allow for the contraction of the welds. So here we go. There we go. 4 tacks at that side too. Okay, so there's the little sliding mechanism. What I need to do now is make sure everything fits as it should. I do think it's going to be tight, but I might be able to work around it, so yeah. Okay, so before I move on to making the face and also testing to see if these insulators fit, they might need trimmed slightly. Hopefully not, but due to the contraction of the weld cooling down, it has made the stainless dimensions, or the inner dimensions, a little tighter than expected. Well, I did expect it to happen, but you know, I thought it might be okay. So it might be okay yet, we'll see. But what I'm going to do here now is I'm going to tack this top face, and then we will experiment, just test if these still fit with the copper bar. It's probably better it being tighter than slacker anyway, for precision of the electrodes. So here we go, we'll tack the top of this here now first. So what I'm going to do is I'm going to tack in the middle, on the 4 edges. So at the minute I've only got the 2 faces tacked. One side done. Okay, so now I'm testing these insulators, seeing if they still fit. So first thing first, I'll let it cool down. Okay, so after a lot of filing internally, so what I've done is I've sat and filed this out for about half an hour because the insulators were too tight against the copper bar or the copper electrode. So no grease or oil has been applied yet. I'm not going to do that until I finish the whole tool itself, until I cut the insulators and install them and stuff. So I'm going to install this now, yeah, to demo how, well, I'm not going to say easy it is because it's quite difficult to get these in. Well, can be when they're new, if that makes sense. So I'm hoping they're easier to put in the next time I go to change them. When I cut them to size, to suit the enclosure this time. Okay, or the capsule. So I'm going to install these now. So what do you see? Placing the sidewalls on first. So 2 sidewalls in. Then I'm placing the lower insulator in. Okay, so we're now ready for the top insulator. And then what we can do then is we can push the copper bar in between them. And hopefully it's nice and tight. There we go. So the copper bar's in there. I'd rather have it tight than too slack. So if I was to get this other copper bar now and push this one, so you can see there it's nice and tight. It's obviously too tight. We want this to spring back the electrodes. But when I apply grease, and yeah, hopefully it frees out. So we're going to make the faces now for this little device. All going well. Slow process. Time consuming. Very time consuming. But we're getting there. So this is the slowest part, obviously. Then we'll work on the mount that will hold the second electrode. Okay. Okie dokie. So I have the electrode in the little capsule. I have the barriers, the insulators surrounding the copper bar. So if I was to do a test, continuity test now from this point to the stainless steel to the copper even, they are isolated from each other. So no electric current can flow from the copper bar to the stainless capsule. Okay, so what I'm going to do here now is I'm going to cut these insulators. So I'm going to mark them with the Stanley knife, and then we're going to cut them off the grinder. After that, I'm going to move on to doing the faces itself. So 2 faces. This one at the side will be fixed, so it'll be welded at 4 points. I'm not going to weld this completely because it'll only contract and shrink. So I'm just going to demo this copper bar now, pulling out before I move on. So if I hold the insulators, the barrier, I should be able to pull this copper electrode out. Oh, there we go, so it's nice and tight. The way we want it. So when I apply grease and use this thing, it should slacken. So we don't want side play and we don't want play this way on the 2 axis. That's why it's so tight. It will free out when I start using it. So if I push it on here again, there we go. Okay, so I'm going to make the faces now. So I'll draw it out here first. Okay, so before I move on to mounting this second electrode to this stainless body that I created, the next thing I have to do here is make a little plate that holds the insulators into the capsule, or into the pocket here, this stainless pocket. So I'll do a wee diagram here. So we have the stainless surround, and at the minute we have the copper electrode sitting there, just at this point. So then we have another barrier, and then we have the bottom barrier. So 1 barrier, 4 insulators makes a barrier. So we need a plate now that sits on the face here at this point, here. Also the height of the stainless enclosure, or the little pocket, or the capsule. Then we need it to come right in to hold the insulators. So the important thing is here is they're held just enough, but there's not enough stainless to go in and short circuit to the copper electrode. So this is important. There needs to be an air gap around the copper electrode. So this body is always isolated from the copper bar. So again, I'll just draw a new drawing here to be seen. So it will look like this when it's finished. So this is a copper bar. We will have a little pocket right round like that, and it will be welded at 4 points, tacked like so. So the copper bar can slide in and out, and the insulators stay in position. Then when we're done with this one, we will then work on the other side. So the other side needs to be mounted in 2 positions. So I'll probably have some sort of a wee fixing here at this point to hold the insulators at the back. So the reason I'm doing that is to allow ease of changeability at the end when the device, well, just say that these insulators become damaged or something. We don't want to start cutting this little capsule open again. So that's the reason we're doing it like this. It mightn't be fixed using a screw, it might be done a different way, but first things first, we're going to make this plate at the front. In fact, we're going to make 2 plates identical, and then we will do the altern to the rear end of this to make this one mountable. So we can slide off and on to remove the insulators. So here we go. Okay, so hopefully you can see these scribe lines. So on the left here, circled, we have the plate that will be welded on to the front face of the capsule. So it'll be tacked in 4 points. This one, circled on the right, just ignore these lines in between. This one circled on the right is the rear end cap. So this cap will be mounted to this end, the opposite end of the capsule, from the face that will be welded. It will be clipped or screwed, I am not sure yet. But before we do that, so I have to focus now on these square holes. These need cut out somehow. So I'm probably going to drill them first, and then I'll use a Dremel to gouge the rest out. So these holes are important, that they're not too small and not too big. If they're too small, the stainless enclosure will come into contact with the copper electrode, and we don't want that. If they're too big, the insulators may fall out. When they tend to slacken, when so many times the machine's used, or the system's used, or the mechanism. So yeah, I'm going to start boring these holes now, and then well, hopefully it goes alright, because it's kind of very small, the squares, like if you compare them to my finger. So the slots will be 5mm wide, or the square holes, and both of them, and they are 17mm long, so quite small. So we'll do this now. So that's why I'm doing the internal cutouts first, because something to hold on to, such as this big plate. So we'll take it from there. We'll go ahead and cut this now. Okay, so we're ready to rock here now. Okay, so I should point out, it's important to keep the drill bit center of the square hole. The drill bit I'm using is 3mm, so the hole is 5mm square. So what I'm going to do is maybe go out to 4 and scribe the rest out to 5. So here we go. So we might get 4 holes in this, or maybe 3. Might get 4. Okay, so it's not easy. So we have, I don't know if you can see that, 4 holes close together. We'll move on to the next one now. Okay, so you may see I have a little problem. Okay, so when I was drilling the holes, no matter if they're center punched or not, because I'm boring stainless, it's very hard to keep the holes close together and lined up in a nice parallel line. So what I'm going to do here, well, forgetting about each one of the ones that I have scribed, I'm going to what I have done is I have bored a couple of runs of holes, and then I have selected the ones that look the neatest. So what I'm going to do now is I'm going to see these 2 that are marked here in the squares. As you can see, the holes are nicely lined up, not far out. So it'd be nice at this moment to have a laser machine to cut this out, or for somebody to be able to do this for me, but there's not in this country. Nobody wants to do anything free in Northern Ireland anymore. So this is why I'm doing it by hand. So what I'm going to do now, I'm just going to use the Dremel and a little reamer to ream them out to the size required. So that is 17mm by 5mm. Hopefully the Dremel works. We might need to change the tool to do this, but here we go. We'll go ahead anyway. Okay, so it's a slow process, but you get the gist. So what I'll do is I'll take loads of pictures of doing this, keep everything logged, and take it from there. Okay, so I went ahead here and have removed these two plates. So I selected a run of holes at the end of this plate at this side. So we don't need this plate for the meantime, this bigger one. So I have already started, well, the two of these plates, I have started gouging out the holes to match the scribe lines left by the Stanley knife. So this one now measures 17mm by, what do we see? I think it's 4.8. Yeah, 4.5, sorry, by 17mm. So my next step now, well, I'm going to demo doing the other plate too. So these plates still need cut externally. So the outer perimeter still needs cut. The reason I've left them bigger is just for more control when I'm filing them and cutting them with the carbide burr and the Dremel. So what I'm going to do here now is I'm going to start demoing this using the Dremel, finishing off this other plate. First things first, I'd like to point out, do you see the small radius left by the drill bit? These radius, the 4 points, the 4 corners of this shape here are cut out using the hacksaw blade first. So basically putting the blade back into the hacksaw like so and cut it nice and sharp to give a nice crisp and clean 90-degree corners. So then I turn the hacksaw over the body and do the other side. Once this is done, I use these little small files to tidy up the hole to bring it up to this standard. So I have to do another plate here now, then I'm going to cut the outer perimeters to match the body of this sliding mechanism here at this point. Then I'm going to weld one on directly. It's important how this is welded to this body. You don't want it to contract and tighten up the copper bar within the capsule, the little wafers, the insulators. So my next step now is to do this second plate. This plate will be, or either one of them, will be mounted using some sort of a catch mechanism. Or are we like maybe by placing 2 holes here and 2 plates at the side of this one with 2 sort of bevels that catch into the side of it. I'm not going to get into that now, there's a lot of work on this, so yeah, I'm just going to start going through the different stages of the square hole with this one. So I'll do that now. Okay, so with the plate sitting on the hacksaw, what I'm trying to do here is remove the round corners. Important not to go too far past the scribe line. Okay, so that's that one done. If you look in, you can see how it's much more square now. So I have it turned already, but I'll just demo how I do this here. So slack it on the blade and basically just turn it over the body like so. You could also just use your hand for this, but I like to use the hacksaw. So here we go, back in again. So 2 more corners here of this plate, then we'll start using the wee small files. So the hacksaw blade is just the more effective at this stage. The wee miniature files are good, but they're not for removing large amount of material. So it's probably hard to see how what I'm doing here, how the squares appear, the square edge. So basically just forcing it into the round radius. So that's it now. So I'll remove it here. So there we go. We have the square edges there now. Better. So we're going to get the files now and start yeah, shaping it even more. Okay, so using these little files to improve this inner perimeter. So we want it like a rectangle. We don't want any well, uneven edges. We want it nice and neat to match the little capsule itself. So the one's picking up there now, so hopefully you can hear me nice and clear. You won't probably be able to see the scribe line, but I can see it here. It's very fine. So there's a bit to go, so I'm going to keep filing here. Okay, so I'm going to stop the camera and I'm going to continue on. I'll take loads of pictures as usual. Yeah, so we'll continue on with welding or cutting the plates in a wee minute. Then we'll start welding them on. Well, one of them first. Okay, so I have the 2 plates filed. The holes now measure 17 by 4.65 or 4.7, I think it is. So the next step now is, well, first things first, I have to mark the outer perimeter of one of these plates. I'll probably pick this smaller one. So I have to mark the outer perimeter, but to do this, I have to centralize the plate to the copper bar. So there's a nice even gap or a nice even perimeter line around, or sorry, a gap around the outside of the copper bar. So what I'm going to do here is I'm going to apply a bit of epoxy resin to the stainless at this side and the stainless at this side. And I have it mixed here and all, so I'm going to do this now. Then when it hardens, I'm just going to flip it over the body in its exact position and scribe it with a scalpel or a Stanley blade. So we get a nice neat line so we can file up against, or up to, sorry. So we can cut the line against the line and then we can file it nice and neat, nice square edges before we weld it on. So what I'm going to do here now is I'm going to apply a bit of glue here. Not too much, because we don't want it to get in the way of everything. We also don't want it to be near the insulators, because we want these insulators to slide in and out in the future. Okay, so that's enough. I'm going to let this harden once it's set here, set on. I should probably have some sort of way of holding this first, so I'll use this shifter. We're just going to set the plate on here now. So a small plate first. Okay, so that's it. So let this harden, we'll scribe it, and then we'll cut it. Then we'll weld it on. Tack it on, 2 tacks. Okay, so now that that's glued, what I'm going to do is mark the back face simply by turning it over the body and scribing it with the Stanley blade. Okay, so we'll cut this out and then we'll move on to the back plate. We might weld this one on first, or I might get the other plate ready. We'll see. Okay, so we're going to mark this one a little different. So this plate needs to be the same size, only it's going to have 2 tabs coming down the side. They will be welded directly to this plate and some sort of a catching mechanism. But first I'm going to scribe this and then we're going to cut it too. So this one's just pinched with my 2 fingers, holding the face to the body. So we'll scribe it here now. There we go. So that's that one ready for cutting too. Okay, so that's 2 cut out. We're going to file them here now and then we're going to start welding something together. We have to cut 2 tabs too also for the side of one of these plates. So we'll do that too also. Okay, so I have the 2 little, well, what shall I call them? Little faces finished to contain the insulators, to hold the insulators in place. So my next step now is cutting out the catch for the side. So what I'm going to do here is I'm going to cut 2 pieces of stainless 2mm. Let me see what width this is. I think it's approximately 11mm. Okay, so I'm going to cut 2 bits of stainless 11mm by 10mm. So 11mm wide, 11mm deep, and 10mm this way. Then we will work out a way of fixing it to this body so that we can remove one of these faces to remove the insulators if need be. The other face will be welded directly to the side But first we're going to start cutting these two small plates first. Okay, so that's the little plates complete for the mechanism that will contain the insulators. So yeah, so we have them up to the same spec of a laser machine. Who needs a laser machine when you've got a grinder and a set of hands? So we've got these two lovely pieces. One of them will be fixed and the other one will be mounted. So I'll just demonstrate that. We have this faceplate, which will be probably tacked at this end. Doesn't matter if it's this end or this end. Either or, so it will be tacked in 4 places. Not too much weld because you don't want the whole thing to shrink. Then the whole device will be useless. So at the other end we will have another faceplate and we will have 2 tabs down the side like so. So let's see if I can get this held up here. So these 2 tabs will be welded directly at the faceplate where my finger is here and here. And then we will have some sort of a way of fixing it. I have thought about screwing it with 2 M3 screws. So I'm going to look at that now and then we're going to move on. But yeah, so I'll start, I might think about boring holes in these tabs first and then we will take it from there. We've only got 2mm of meat to hold the wee screws. What do we see? I was also thinking about clipping it rather than screwing it, but I think screwing it would be much stronger and yeah, it'll be better in the long run. So here's the wee screws. So they're M3 dome screws. So I'm going to try and bore these holes now as neat as possible here on these 2 tabs. So I have them marked and all. There. So we'll do that now and hopefully it goes well. If it doesn't, there's another way I thought about doing it, was placing a wee bit of weld the same distance in as the hole, so when you push the cap on it falls into the hole itself, or into the welds. The holes fall round the welds. But it might be a wee bit, well, I don't know if it'll work, but I might go with the bolt first and then the screw bolt, and if it doesn't work we will go back the other way. Yeah, so we have to tap 2 holes in this body after we bore the holes in this and after we bore the holes in the body. So here we go. Okay, so that's 2 pilot holes bored there. Not easy. They're very small. Okay, so we have a 2mm hole in these tabs. We're going to take them on out to 3mm to match the screw. One done. Okay, so that's the little sliding mechanism, the 2 holes, straight through. So obviously the screw, obviously when I go to tap these, the screw will only be going in 2mm to this body, otherwise it would hit the insulator. Okay, so I decided to tap these holes out to M4 rather than M3. The reason being, the thread pitch is much coarser on the bigger dome head bolt that I'm using, M4. Also, I didn't have a 2.5mm drill bit for the M3 dome bolt screw. So the drill size I used in the end up was 3.3mm, and it is now tapped. The next step now is welding all these little pieces together. So again, we have the two tabs, we have the front facing plate, and we also have the plate that the two tabs will be welded to. So I'm going to follow on with this now and hopefully it all goes well. Okay, so we're at the final stages. Today's a new day. There's a storm brewing outside, so I've decided to come back further into the garage. So I'm going to give a little explanation here of what I'm doing, then I'm going to start welding this together, the tabs that I've created. So in between these two plates is obviously the mechanism that I'm going to weld. So the reason I have a sandwich between two aluminium pieces is obviously to protect the mirror, but also it holds this plate in place until I weld it to the two tabs. So the two tabs are screwed in with M4 bolts, M4 dome bolts, what am I talking about? So M4 dome bolts, these aluminium pieces also act as a heat sink, so it disperses the heat away from this focused area where I'm going to weld. So we don't tarnish the mirror too much, and also we don't put too much heat into it, and also so we don't burn the insulators below. So there's hundreds of crows flying about outside and they're making some noise. The lighting conditions mightn't be that great because we're at the back of the shade, but I'm going to go ahead and do the video anyway. So I'm going to put the camera on the stand here now and we're going to motor on at these very interesting stages, because after this I'm going to move on and mount the second electrode to this device, or this mechanism somehow. So I'll put the camera on the stand here now and we'll weld this together and then we'll move on to that stage. Okay, so I forgot to mention, if you look closely here you can see the copper bar protruding through this little piece of stainless that I have created. So you can see there's a nice even gap, I'm going to call it an air gap, right around the copper bar and between the stainless. So this is crucial for this little mechanism to work, or the spot welder itself. If that was shorted, or if that copper bar touched the stainless, it would short the transformer out, which is no good, and will end up burning around this mechanism. So I'm going to put the camera on the stand now, and then I'm going to start welding. So hopefully I get this angle all right here. So I'll zoom in. Okay, so I'll stop and I'll set the camera up and then I'll start welding. Okay, so I'm ready here now. So making sure that this little plate is down tight on the body of the sliding body. So it seems to be tight. What I'm going to do is I'm going to put 4 tacks on it. A tack at this corner, a tack at this corner, a tack at the 4 corners. So away we go here now. I'm going to put 1 tack on it first, then I'm going to take it out and look at it, and then we're going to put it back in and tack the opposite corner. So hopefully I don't get in the way here when I'm welding this, because it's a very small piece to be working with, and doing all this in front of the camera. Is the camera zoomed in? Okay, so that's 1 tack. Okay, so I'm going to zoom out here. I'm going to stop the camera, look at it and put it back in and weld the other side. Okay, so I had to remove it the way it was clamped to a different position. So as you'd expect, when I welded this end, this plate tended to lift at this end. So now what I'm doing is I'm pushing it down. I'm going to place a tack at the opposite side, at the opposite corner. So diagonally across it. So, okay, so if I get this set up at this position, then we can weld. So hopefully I get the camera on it here. It's quite difficult due to the item being so small. So do we see if I zoom in here again now? Okay, so I think that's not bad. Okay, so that's it. 2 tacks. Going to do the rest off the camera and then we'll move to the other side. Take loads of pictures too, obviously. Okay, so we're at the final step of this final stage. So again, I have I'm going to call this actually the rear face. And we're going to call the face that can be, well, removed, the front face. So this rear face now is going to be tacked, again, sandwiched in between the two aluminium plates. So here we go. It's all set up. The gap looked even right around the copper bar. So here we go. So it's important to keep the insulators maybe about 6 or 7 mil below the top face here so we don't burn them. So now moving on to the other side. So we're going to have to clamp it up and down again. Yeah, so when I tack this side tends to raise. So again, just in case I block the camera there, if I tack this side, which I have done, this side will tend to rise up as the heat contracts here at this point. So I'm going to take it apart here again and clamp it at this end, and then we're going to finish off this little piece and move on to the next stage. Okay, so that's it welded together. Doesn't need any more welding than that. We only need to start it if we did. So now we're going to move on, yeah, assemble it, and then we're going to move on to the next stage. Okay, so we're at the final stage of this video. So what I'm going to do here is going to bring the camera down and assemble the little device, and then we're going to do a meter reading and check the resistance between this body and the internal copper electrode. Okay, so I have zoomed in to the table here. So everything on this A4 sheet is the parts that I've created over the last few weeks. So it's been a slow process. There's been a lot of thorough work on it. So I'm going to start off here now. Oh, first things first. So see this multimeter? I'm going to do a final test at the end and check the resistance between the copper bar and the stainless enclosure or stainless capsule. So I'm going to lift this stainless capsule now. So this stainless capsule is the part, the component that contains all the insulators. So I'm going to start off here now sliding them all in to position, their final position. So we'll start off with this narrow insulator. Number 1 we're going to call it. Number 1 insulator slid into the left hand side here. Then we're going to follow on with number 2 insulator, which is wider. So we're going to call this the bottom insulator. So you can see it falls into position there. Then we're going to add in another one, which is another narrow insulator. So this acts as a barrier that isolates the two metallic, well, the stainless steel and the copper bar from each other. So the next thing now we'll add in is the stainless bar. So there's a difference in these stainless bars. One has got wee marks on it, and I don't want to use the one with the marks on it. So this one is the one with no marks. So we're going to slide this into position. So you can see now that that slides through the other end. So at the minute this is still slack and there's piles of play in it. But when I add in the final insulator, number 4, which is the top insulator piece, part, if I slide this in now, everything becomes nice and tight. So what do you see if I slide this in here? I'll slide it in. So if I hold up this way and push this into position, the copper bar now is tight within this little capsule. The final part we attach to this now is the little end cap, which I'm going to call it the rear. I wasn't sure if it was going to be the rear or the front in the video clips, but it's the rear. So I'm going to keep this to the rear of the welding process, which will be at this end at all times. So basically what I do here now is I am going to mount this back on to where it was welded. So that's just the meter beeping there, forget about that. So we have a little mark in the inside here, and we had a little mark here. So these correspond to where it sits on the device. So it's just made to match. So if I slide this on now, like so, maybe give it a little tap with this copper bar. So that's the reason I didn't want to use this, because I left me marks on the side of it, tapping this on. Shouldn't be doing that, but it's going to be cut anyway. We're not going to require the full size of this copper bar. So the final two parts I put on to this little mechanism will be the Allen key, or sorry, the dome head bolt, which has an Allen key head. So we're screwing this on, that's one on. So again, these are tapped, these holes are tapped. So that is it. Finished. So just give the bolt a wee sweeten when the whole thing is lined up. And then we're going to do a test with the multimeter. So we're going to hit this with the pliers just to straighten it. Just to pull it into position here. So I can tighten the Allen keys up now. Okay. So it's just a wee knack to get this centralized. Okay, so that's it. So what we have here now is it looks like a piece of metal, but it's obviously two pieces, different kinds of metal. And what happens here, when I push this copper bar, it slides in and out, nice and neat. There's no movement in it, it's tight as tight can be, the way I want it. So that's for precision of where these copper parts, the electrodes, will meet for the spot welder. So if I do a test on this now with the multimeter, set it into ohms reading. If I go from here to the copper bar, we have open loop. So that's telling me there's the meter is unable to read anything. So there's a extremely high resistance there. The only time voltage will ever jump from this copper bar to this stainless if the voltage is very, very high, within kilovolts like. So as you know, I have done initial test on the transformers for this device, and the voltage on the secondary winding is 1.75. So it's never going to jump. So if we look at in here now, we can see a nice air gap between the copper bar and the stainless surround, the stainless capsule. It is also the same at this fixed end. So that's this little device completed. It's moving nice and freely. The next part that I will follow on here will be a spring to pull this copper electrode back, and also we will follow on to mounting this copper bar at the side of it somehow. So remember, this is a miniature spot welder, so everything is to be kept nice and compact. So that's it, all finished. Next step, we'll move on here. Okay everyone, so that's part 2 complete. I didn't think it was going to be as long as it was, but there clearly was a lot of work in making this little device. So in 3 to 4 weeks time, I will upload part 3, which will focus on, well, attaching this copper electrode to this body. So there will be a branch or an interlinking point, which will be made out of stainless also. I'm probably going to weld to this body, and this copper electrode will be at this side, or it might creep in this way. We don't know yet. So I'm going to start working on this later on today, maybe tonight. We will see. But for the meantime, yeah, that's it. That's the video complete. If you want to stay and watch the rest of the images of the design process, no problem. I'm not going to stop you. So, we have a car now. they have a car and it's actually the police. Oops. So I'm just going to finish this video up. If you have liked this video, give it a thumbs up. Don't forget to subscribe and turn on the post notifications bell. So I'm getting, I don't know what they want. I wonder if I was reported for sitting on the pier, but who cares? I'll turn the camera around in a minute. I'll turn the camera around here, do you see? And I'll just say goodbye. Goodbye. Take care. Are they looking at me? I think they are. I can feel the eyes burning in the back of my head. Goodbye everyone. Okay, so additional manufacturing stage. So here I'm just going to discuss quite a few images, photos that were taken on the day of the manufacturing process. The different stages. So on the A4 page here we have all the little formed parts ready to make one component, which is the sliding mechanism. So I am using Jenga blocks here to clamp the little component together. However, I did change from using the Jenga blocks to, well, using sheet aluminium instead, as the Jenga blocks were sinking into the edges of the stainless, causing problems, causing the faces from being too tight. Also, the aluminium material sucked the heat in whilst it was being welded, so it didn't burn the insulator, the barrier below, so that was important. So this is the little capsule complete. I call it capsule pocket enclosure, but it's more of sort of like a wee pocket at the minute. So yeah, it's getting there at this stage. So the insulator, the barriers, sitting in there nice and neat, ready for the front mounting plate. The plate to be welded, and also the plate at the rear end that can be screwed off and on to remove the insulator, the barrier if needed in the future to replace it with damaged. So at this stage was a tricky process because the drill bits were all blunt, the wee small drill bits, and even at that it's just quite tricky to bore small holes in stainless steel. The stainless is very sore in the drill bits. So here I am gouging it out. I have gouged it out using a Dremel, and I'm ready for the hacksaw blade as demoed in the video clips, and also the filing, the small miniature files. So lots of wee photos here of the manufactured stage. This is what I would take them. So here you can still see the radius in the corners in there, so they needed hacked out with the hacksaw, then filed, so you can see me cutting them out here. And it's sort of taking shape at this point. Then after this hacksaw blade, the wee miniature files were used as discussed. So you can see them taking shape there now, especially this one. Ready for the little tabs to be welded on nearly, but a lot of wee filing to do yet. Okay, so this is the bigger plate that these two small pieces were cut out of. You can see it sort of taking shape at this point. So the external perimeter needs cut yet. And here what I'm doing is I'm lining them up and marking them ready for cutting process. The cutting process. So you can see the scribe line at this point. Using the Stanley knife. Held with the vice grips. Obviously because they're that small. So one cut at this stage ready. Well, it needed tweeted with the grinder. Then filed to give them a nice flat edge, or 4 edges. So you can see here what I'm doing is I'm making the tabs. At this point I've marked them out for the 2 pilot holes, which turned out to be 4mm in the end, as the hole in the actual capsule was tapped out to M4 for an M4 dome head stainless screw bolt. Okay, so the final images appearing here now is just the welding process of the little clip, the little U-clip, C-clip, whatever you want to call it. So you can see the nice air gap, I call it, around the actual copper bar there. So this is important in order for this little mechanism to work. If it was too tight, the copper would arc out with the stainless and short the transformer. Okay, so a couple of photos here of the little device before it was welded. Well, the C-clip, the little bracket there at the front that holds the insulator pieces in. So here we have it welded, finished. Well, actually after the welding stage here, I did prep the surface, clean the surface up, and apply the brush finish back into the face. Okay, so these final few images here is of the welding of the fixed face. Tacking it on, so the G-clamp again and the 2 aluminium pieces being used to line the little face up for welding. Okay, so that's part 2 complete of this little project of this sliding mechanism for my wireframe welder. So if you've enjoyed this video, do give it the thumbs up or hit the thumbs up, and also please subscribe to my channel to see more interesting projects in the future, such as this one. So I will be continuing on with this project in hopefully 4 weeks time, and I will be finishing the handheld device and moving on to combining the system as one. So thank you for watching everyone, goodbye.